In this section, we are going to introduce a second way that we can multiply two vectors together. If you remember when we first started energy, we introduced what we call the dot product or scalar product, and that's the first of the two ways that we can multiply vectors together. So here I'm going to do a quick review of the dot product to help highlight the difference between the two and connect it to what we're trying to do when we're introducing the vector product. So I have two vectors here. I've got vector A and B. I've got angle theta between them. And if I do the dot product, I've got A dot B, and that is equal to AB cos theta. And remember that this is scalar, right? So this is not a vector. So when we do dot product, we're producing a scalar. A dot B is equal to B dot A, right? I can change the order of those, and then this would just be BA cos theta. So those are going to give us the same values, the same magnitude, and we don't have a direction. And so those two things are equivalent to each other. Importantly, what I want you to think about is what are we doing when we're doing dot product? And if we think about those two vectors and what we're trying to do, we can take that vector A and make a component that is parallel to vector B and a component that is perpendicular to vector B. And that parallel component is equal to A cos theta, right? So that's like this piece here. So when we're doing that dot product or scalar product, what we're trying to do is to take the component of one of the vectors that's in the same direction as the other one and multiply those two things together. And if you, again, think about what were we doing when we did this? So we had our displacement vector, our force vector. And so we're trying to take that component of the force that was parallel to our displacement. And so if I have a force in the same direction as my displacement, that means I have an acceleration, and that means I'm going to change that kinetic energy, right? And so that's what we were sort of doing. That was our goal when we were working with that dot product. So now we're going to introduce another way that we can multiply two vectors together, and this is called the cross product, vector product. And the end result that's different here is that we're going to end up with a vector, not a scalar quantity. So again, I've got two vectors, so I'll call this one A, and I'll call this one here B, and we've got angle theta between them. So when we do cross product, we're going to do A, and we're going to cross. So instead of putting a dot, we're going to put a cross in between them, and this is going to equal AB sine theta. And I'm going to put a little absolute value here. So when we do this, the AB sine theta, that's going to be the magnitude of the cross product. We are going to still need to do direction, so we'll talk about that in just a sec. So when we do this AB sine of theta, if we do kind of the same thing where I think about what are we actually trying to get at here? So if I have vector A and vector B, so again, I can make a perpendicular and an A, and I made that vector kind of long up there. So let me move my little B here. I've got my parallel component down here. Let me redraw that piece. There we go. Okay, so here's my A parallel. And so what we're doing here is I've got A parallel. This is my A, B, or sorry, this is just A sine of theta. There we go, A sine theta. And this one here is A cos theta. A cos theta. All right, so if I look at up here, so this is A B sine theta. I can reorder that. So this is B A sine theta, so I could get it to match my picture. So A sine of theta, if I look at this one, now I'm taking this perpendicular component, right? So in the dot product, we're interested in that parallel component, multiplying that by the vector. When I'm doing cross product, we're interested not in that parallel component anymore. We're interested in this perpendicular piece here. If I do, I'm going to draw the same thing over here and do this from the other perspective. So if we do the B vector, break that into components. So I'm going to have this piece here. This would be my B parallel. And then this here, this would be B perpendicular. And again, B perpendicular, this is going to be B sine of theta. right? So in either case, what we're trying to do is we're taking this perpendicular component of one vector and we're going to multiply it by the other vector. So the difference between one big difference between dot product and cross product is that component of the one vector that we're multiplying by the other. So dot product, parallel components, vector cross product, we're looking at those perpendicular components. So again, this is only magnitude. So I'm going to make that little note here, right? This gives me magnitude. So when we do vector cross product, we also need to indicate a direction because the result from A cross B is going to be some vector that has this magnitude. So I have to indicate the direction. One of the ways that we indicate direction is something called the right-hand rule. And I have the directions for how to do this here. This is a little difficult to do over a video. So when we get to class on Thursday, I'll have everybody actually practice doing the right-hand rule to determine the direction of our product, our cross product. But we're going to take our fingers in the direction of A, face your palm towards B, curl your fingers, and then when you do that, your thumb is going to point in the direction of A cross B. So one thing that we can remember is, and I'll just write these two pieces out here. If I do A cross B, that's going to equal some vector C. If I do B cross A, right, this is going to equal negative C. So the order of the cross product, the order that we write that does matter. So the magnitude will be the same either way, whether we're doing A cross B or B cross A, but the direction is going to be different. And when we do direction, so the C vector, so what we'll end up doing when we do that right-hand rule, C is always going to be perpendicular to the plane that A and B are in. Right, so if A and B are in the plane of your paper or your screen, then that vector C is always going to be perpendicular to that. So either coming out of the paper up or down into the paper there. So when we're doing vector cross product, so the relationship that we want to recognize is it's going to be AB sine of theta, so magnitude of both vectors times the sine of the angle between them. And then the direction is always going to be perpendicular to the plane that those two vectors are in. So either into that plane or out of the plane. And that's going to depend on the order in which we are doing the cross product. So either A cross B or B cross A.